Well, thank you. Hopefully you'll find this interesting. Obviously I'm interested in light pollution for a lot of the same reasons you are, but having gotten into this for quite a number of years now, I've discovered that there are many more issues in light pollution than meets the eye, to use that one, but that actually may be some of the more important effects and may be useful in terms of controlling light pollution. A lot of it's fairly brand new. So this is the reason why, of course, I'm interested. That's my observatory. All right, so we all know what light pollution is. Everyone in this audience does, so I'm not going to spend time describing what it is, but clearly, if you can see the Earth from space, there's too much light going up. And we all know the consequences of light pollution are sky glow, visual impairment. There's environmental consequences. One of the main reasons why a number of animals aren't procreating or finding food at night. But there are, and we all know about energy waste, but the human consequences are much less well known and are now getting on the map. So glare is the most common one. I've already got the AMA to adopt that as one of their policy statements in 2009. And we all know what glare is. Sometimes it's hard to define, but this is glare. Okay, and this is a well-controlled light so that you don't have glare. The question is, why is it bad for us? Now, here's the definition from the U.S. Department of Transportation. This is what they call glare. You don't have to read the whole thing, but basically if it shines in your eyes and interferes with your vision, that's glare. So let's define that a little bit more and why that happens. Human eye, all the light has to go through the pupil. At night, when you're dark adapted and you're young, the older you get, the less well this works, but you dilate to about 7 millimeters. And if you're in a light polluted area or in a bright light, you constrict to about 1 millimeter. That's a difference of 50-fold if you do the math in terms of aperture and light gathering. So if you're trying to see well at night in dark areas and you're constantly being bombarded with street lights that aren't shielded, your pupils are constantly constricting, okay? And in fact, what that means is you're driving around in your car with your eyes basically closed to a slit, allowing only about 10% of the available light in. Needless to say, that's bad, and it makes all the non-lit areas look even darker, and the natural politicians or average public's response to having dark areas is, of course, put up more lights, right? Waste more energy. That's not the right answer. The answer is to shield the lights so the dark area, your pupil stays dilated and the dark areas don't look so dark. So why does disability glare make things less visible? It's a scattered light in the eye and it decreases contrast, just like dirt in a lens on a windshield, just like dirt in a telescope decreases contrast. So what is the effect of disability glare? If you're in a dark area and you're just using your headlights, you can see very well about 220 meters down the road. That's pretty good. But if you have street lights or headlights shine in your eye, your visibility is down to about 40, 80 meters. And if you're going 60 miles an hour, what's your reaction time and what's the design of the car to get you to stop? Basically, you don't stop in time if you see something, whereas if you had well-shielded lights, you could actually see down the road far enough so you could stop safely in time and avoid accidents. So it is an important factor, and just now the government's finally getting interested in it for that reason. So here's what the human eye does. Do I have a pointer?
Yeah.
Is this it?
Pointer and that will also change the slides.
Oh, okay, good. So where's the pointer?
Right button.
Right button? Thank you. Whoop. That's the wrong button.
Center, Ariel. Center the pointer.
Okay, now we don't have the, there we go. Center. Great, okay. So light comes in, you have a cornea. That hardly ever causes a problem unless you have some specific rare diseases or scratches in the cornea. You have an aqueous humor up front, again, that also hardly ever causes a problem. The main problem is in the lens. I'll talk a little bit about that in a moment. There's some problems with what's called the vitreous humor here, and then you have some retina problems. All interfere with vision and it gets worse the older you get. So you have a cornea that's clear, aqueous unit that's clear. The lens is an interesting object. You have vitreous humor in this, that's the actual photograph of an eye. So let's talk, here's a normal eye, here's an eye with a cataract. It's pretty easy to see. So what's wrong with the human eye? It's a design flaw, okay? The human eye was designed poorly. And one of the main problems with the human eye is the lens. Okay, we weren't designed to live to 99 years old. We were designed to procreate and then die and get off the planet, basically. The human eye adds layers every year, just kind of like tree rings. And the problem is there is no blood supply to the lens. So the older you get, as this lens gets bigger and thicker, the nutrients for the human lens come from the liquid on both sides of the lens. It just diffuses into the lens. The problem is when it gets thick enough, the center doesn't get enough nutrients. And when any human cells don't get enough nutrients, they die. And when the center lens cells die, they eventually calcify. That's basically what a cataract is. It's just dead cells that are calcifying because they're dead. So, disability glare, the light scatters in front of the retina as well. So in addition to the lens causing scatter because of these densities, which eventually form a solid cataract in many people, the vitreous humor on the back of the eye, you have floaters. And those are basically cells that are being sloughed off from the retina, and they kind of float around in the back. You've all seen floaters, and the older you get, the worse they get. And unfortunately, there's no way to get rid of them. And the elderly are particularly susceptible to disability glare. At low light levels, glare becomes a problem. Okay, so old age becomes a problem with disability glare. Let me move on. So here is a well-done study. It's actually fairly well known for many years. The study was done in '77. But I like this one because it shows how long we've known the problem. So forget newborns, because most newborns don't observe much. But if you're 20 years old, you're around 1,500 foot Lamberts, that's the measurement they use, that's the level at which light coming from the side gives you disability glare. By the time you're 60 years old, I'm 59 now, you're down to here. Okay, so basically at 60 years old, it takes 1/3 the light level to cause disability glare than it does when you're 20 years old. Which is why, it's interesting how many people here in the audience have noticed that they have a hard time driving at night whenever there are bright lights, or have parents who do. It's all from bad, and you can blame the engineers, blame all the engineers in the audience. It's bad engineering of the lights. The human eye was designed not to have glare come into the light. If you shield the lights, and this study after study has shown this, I'll show a couple, you basically avoid that disability glare. And in places like Tucson, where they have strict laws for many years, or certain other parts of the country, you can drive at night, and you don't have that disability glare. And the older you are, you notice that you can actually drive safer and not have that problem. But the funny part is convincing the public, because most of the public thinks that if they can't see at night, it's got to be because there isn't enough light. So naturally, they push politicians to put up even more lights. And that exacerbates the problem. So in 2009, it took about a year of effort. I got the AMA to adopt this resolution. And it passed. So now this is AMA policy in all our policy statements that go to governments. So specifically, the AMA advocated all future outdoor lighting be energy-efficient design to reduce waste of energy, reduce greenhouse gases that result from wasted energy, and further that the AMA develop and enact a policy, which they've done now, that supports light pollution reduction efforts and glare reduction efforts at both the national and state levels, and that all future street lights will be a fully shielded design. So this is very helpful, and if you're trying to fight for light pollution efforts in your local town or state, feel free to download this direct from the AMA site and bring it to your local councilor or town government, because I think this helps carry some weight. It's helped in a number of levels, I know that. All right, so what is about glare? I want to move to some of the stuff that you haven't seen, so let's just talk about this for a moment. Any light that goes up is directly wasted. Here's the glare zone, okay, and here's the productive zone. The IDA, which I'm now a counselor on, has recently come out with the MLO, which was 7 years of effort to get the International Engineering Society of North America and the IDA to come up with common language. Some people have signed petitions saying they didn't like that because they go far enough. But I'll simply point out in all the thousands and millions of towns across the country where none of you actually live, you now have the lighting engineers as a matter of policy stating that glare is bad and that this should be controlled. So yes, it probably didn't go far enough, but it's still going to do a lot more for light pollution than anything else we'll talk about today. And that's another subject, of course, but I think the MLO is going to be a good thing. So let's skip that for a moment. So here are bad lights and good lights. We've all seen those. And there's some towns that have retrofitted their lights in New York. We've all seen this. You have a glare on a windshield, and if you have a shielded light, you can see better. So here's a person standing in a local school on the typical globe on a stick, right? And now where is that person? People have seen this before. Standing right here. Okay, so I love to show this at any meetings where people are not convinced. How badly can you design a light if you're standing directly beneath it? You can't see anything. That's a typical bad light. Most of the light from these go up and sideways. Okay, and here's Calgary, Canada, where they retrofitted all their lights. So here up front, the lights have been changed, and you can see pretty well. Light ground's well lit in the distance. All the bad lights haven't been changed out yet, and you've got terrible glare. So it kind of sells itself. I convinced Gloucester with pictures like this, where you have here a school, it's actual church in the center of town, Cape Ann Church. Anyways, they have a school next to it, and they put up the 400-watt glare bomb for security. And I simply showed this at City Council and said, you can have an army running rampaging, stealing everything in this school. You'd never know it because of that glare bomb, right? Salem, where I work, they like to picture themselves as still look like the 16th century whaling area. So they put up these kind of lights because it looks like it did back then. The problem is at night, it's all glare and it lights up the buildings on the side. And if you're driving along at night, you can't see the street, but you can see the lights pretty well, which blind you. In Salem, they did the same thing. They got a federal grant because they wanted to copy that. So they got these whale light type lights, but instead of a one candle light, they got these 400-watt lights that are so bright that all the lights going in the windows, nothing's hitting the ground. Okay, if you look down the street, after all the money that they spent, okay, the buildings are lit up pretty well, and so all these people are buying shades, of course. But the actual light in the street, you've got more light coming from the tail light of that car hitting the street than you do from these. Okay, again, very bad engineering. East Hampton, they had bad lights, got a lot of bad accidents. They moved the lights up, and now it looks better, and they have better lights with less accidents. So if you're going down the street, a typical highway, the Department of Transportation requires the lights to show you if there's an intersection. The problem with that is if you're just beyond the cone of light, you wouldn't see that there's a person standing there. All that person did was move up 10 feet. Okay, that's the danger of having glare lights. It causes accidents. Whereas this is a shielded light, then you'll be able to see much better. Let's skip that. Okay, the second part, another medical effect of light pollution is the energy that goes in to produce it. It creates air pollution. So for every kilowatt, because 96% of the energy we produce in Massachusetts is from fossil fuel, in Indiana it was like 99%. So for every kilowatt it causes a release of 1.3 pounds of carbon dioxide, 2 grams of sulfur, 1.6 grams of nitric oxide. Doesn't matter if it's coal or oil, the numbers vary slightly, but there's quite a bit. So in Indiana alone, in 1 year, 62 billion kilowatts comes out to 40 million tons of carbon dioxide, 1.4 million tons of sulfur. So if you have asthma or if you have a lung condition, wasted light means air pollution, which means bad health. Put it another way, it's from National Geographic, half ton of coal is used to have a 100-watt light bulb, which is a typical street light, from dusk to dawn for the year. Multiply by the number of street lights in your town, and that's how much energy is being wasted and how much air pollution you're getting out of it. It's quite an amazing number if you actually stop and look at it. But let's talk now more a bit about some of the other medical effects of human health. We all, and that's specifically what I talk about is circadian rhythm. Okay, so air and water pollution, health problems, we talked about that. Melatonin suppression is circadian rhythm disruption. It creates sleep disturbances. It's suspected in childhood leukemia, but it's especially prominent in all hormone-induced cancers. I'll talk about that in just a moment. We talked about glare, and of course, it's our natural environment, which is being degraded. So, back in 1987, due to a number of preliminary studies, Richard Stevens, who's a researcher at the University of Connecticut Medical School, how many people from Connecticut here? Okay, he's a good guy, and he's put this on the map. There are a number of researchers on it, but he was actually the first one to do some of the initial studies. So Richard Stevens put together this hypothesis that exposure to light at night suppresses the pineal gland melatonin production. That's actually known, it's easy to measure. And that may explain some of the high unaccounted risk of breast cancer in industrialized societies. In the 1990s, a number of preliminary studies were done, and each one had a p-value of less than 0.001. People still were skeptical, saying, how can that be? So they did much larger studies in the last decade, and these studies all have the same result. There are now something like 40 well-controlled, double-blind studies that show that interfering with circadian rhythm, suppressing melatonin, is a direct cause of a number of hormonally induced cancers, and breast cancer is one of the most important of them. I've got 5 people to, that's my next project. I've submitted a proposal to the AMA, and they accepted it, and where I'm going to be basically editor in this. The real experts are specifically Stephen Lockley from Harvard Medical School, Richard Stevens from UConn Medical School, George Brainard from Thomas Jefferson Medical School in Philadelphia, and finally David Blask from Tulane. Needless to say, these are all well-respected research institutions. They've done all the basic research for the last 15 years, and they've agreed to submit their research as part of the monograph that I'm going to put together. And I also got Ronald Gibbons from Virginia Tech. He's an engineer who's done a lot of the glare research. So I'm hoping for about a 30-page paper, which will be ready by about the end of this year. It'll be submitted to the AMA, and then that'll be published as a monograph, which will basically summarize the world literature and everything I'm going to talk about next. It'll be submitted to all government agencies, and especially lighting companies, so that they don't produce bad lighting. It's already had an effect. Anyone get the September issue of Sky Health? It was just coming out. Anyways, I have a one-page thing there on focus point on light pollution and how it affects human health like this. It's very just a brief introduction. But I already got an email from some engineer at Osram who wanted to know about it because they didn't think that blue light and lighting in general caused this. So I sent them a whole number of articles, and they're discussing it in their engineering department. So the more we publicize this, the more I think the lighting companies will come around naturally. So let's talk about a little bit about melatonin and what it is. It's a hormone that's produced through the pineal gland, which is dead center in the middle of the brain. but it has direct connections from the retina to the brain to that, and it's very much light cycle induced for production. So that's what it's a hormone, as I said, produced by the pineal gland, has a strong daily rhythm. Your melatonin production is low during the day and rises at night. Disruptions in melatonin have been directly linked to mood and depression. That's why lighting therapy works for many people who have depression in midwinter. It affects reproductive physiology. Many women, it turns out, have difficulty, since that's clearly hormonally dependent, have difficulty conceiving. It turns out may have not been getting the proper amount of melatonin because, I don't want to get too deep into this, but that has an effect there as well. And it probably fights breast cancer because breast cancer is a strong hormonal type cancer. It inhibits breast cancer in rats, and I'll show you one of those studies. It slows human breast cancer cells in culture. So here's what the normal melatonin level in human is. So during the daytime, you have about 10 to 15 picograms per milliliter of blood. At night, it should go up to over 50. And if you're a typical household that gets up a lot at night because the bathroom turns on the light, has a night light on all night long, your levels are significantly reduced. That's already known. So the question is, what effect does it have? So if you were to say, what causes breast cancer? There are a number of possible causes. For a number of years, people thought, I should say I'm a cardiologist, I'm not an oncologist, but I'm going to give you summaries of other people's research. So if you were to say, what causes breast cancer? For many years, people thought, geez, it had to be our diet. It had to be toxins in the water, toxins in the air, right? Anything except what you would think about would be lighting. But as it turns out, if you look at this graph of breast cancer rates, it's highest in North America, lowest in China. Who has the worst air and water, the U.S. or China right now? So it's clearly not toxins. If you look at, so here's North America and Western Europe. Eastern Europe, which has a much lower lighting level, has much lower levels, and they have worse environmental disasters in Eastern Europe compared to Western Europe. Japan, Africa, and then finally China. So basically areas of the world that have low lighting levels don't seem to have as much breast cancer. The more lights you have in the population centers, the higher rate of breast cancer. That's epidemiologic, that's not proof. Okay, so we've evolved to have a daylight cycle. Okay? Lots of light in the daytime, dark at night. That's what our human physiology has evolved to. But in modern life, we have restricted days inside buildings, low light levels, and then light at nights. It's completely changed what we've evolved to. So, for millions of years, we had a daylight cycle. Now, with electricity, for 120 years, we're having shift work, late night reading, TV, and we lit bedrooms during sleep, not dark, bright bathroom lights, night glow over cities. So light and melatonin, you have intense suppression of nocturnal melatonin in everyone. And that's been known since 1967. I've got 1980, that's the page. Spectrum, Joy Brainerd from Philadelphia has shown that the blue light is the most effective at suppressing melatonin. And unfortunately, our TV screens and our computer monitors are intensely blue light and cause a lot of suppression. Red light is the least effective at suppressing it, but even a bright red light can cause suppression. And then, of course, there's human variability. Some people are just more sensitive than others. That was published in Lancet in 1990. So here's a typical night. Remember I said normal goes up to 50. So here you go to bed at 10, your melatonin starts to rise. It never gets up here. You turn on a light to go to the bathroom or read for an hour, it immediately drops. And then it starts to rise again when you finally fall back asleep again. So basically, if you wake up for an hour at night, your melatonin levels are very much suppressed. And this is multiple studies have shown this. This one happens to be from Lancet. So this is the paradigm. We thought we knew what caused breast cancer 25 years ago. Turns out we don't. Because all the studies have shown it's not diet, it's not toxins. There is about 20% genetic, but it turns, most of it we still don't know. It looks like lighting is one of the strongest causes. So where are we now? Here we go. These slides are from Richard Stevens from Connecticut. He's done the most work on this. So breast cancer in industrialized society. 20% is the level in non-Westernized societies compared to U.S. First generation immigrants, if you think it's genetic, it wouldn't change, right? But if you have Chinese immigrants that come to the U.S. within a generation, they're just like us. So it's clearly not genetic. Random mutations account for some of it. Those are the certain cancers that are not hormonally. There's two types of breast cancers, hormonally dependent, non-hormonally dependent. So then there are known risk factors, but almost 50% we don't know what causes it. Okay, so what is it? Now let's talk about the lighting aspect of it. So breast cancer and light at night. The theory is that light at night alters the hormones, suppresses melatonin, and melatonin is a known cancer suppressor. If you have high levels of melatonin, you tend not to, if you have a cancer, it tends not to grow as fast. And in multiple cancers, mostly the hormonally dependent cancers, and there are a lot of them. In men, it's prostate cancer. That's intensely hormonally dependent. It doesn't do much for like lung cancer, okay? That's non-hormonally dependent. That's an alternative. So there are predictions you can make for that if that hypothesis is correct. Shift workers will be at higher risk. They're constantly disrupting their melatonin production. Blind women would be at lower risk. Lighted bedrooms at night increases risk. Long sleep lowers risk. Well, every one of those has been proven to be, in actual fact, the case. So you have various research, basket research. This particular type cell was grown in nude mice. Not that the research is voyeuristic, it's just that's a good model to work with. And they transplanted human breast cancer to adult nude rats and fed arteries into it, and then watched the tumor grow. So here's the result. This is a pretty dramatic result. So here you have a mouse with human breast cancer, and if it's exposed to a 12-hour day-night cycle, here's the rate of breast cancer growth. If it's exposed to light all the time, here's the rate of cancer growth. And depending on how much light in between, 1 hour on, 1 hour off, et cetera, it's a direct correlation. The amount of light directly impacts the rate of growth of the breast tumor in the mice. Blind women. This was done in the USA, in Sweden, Finland, and Norway. And blind women have a much lower rate of breast cancer, even living with other people who have sight as controls. So it's not the environment, it was strictly the melatonin production. Blind women have a higher level of melatonin. Here's a study that came out of Oslo. Okay, so breast cancer in sight women compared to blind women, the relative risk is in the US 1.75, Sweden was 1.5 in Norway. And if that hypothesis is correct, then about a third of all breast cancers in the US are related to lighting issues. That's a huge number. 20% are clearly genetic, and the rest are in between for other causes. More studies on shift workers, Finnish flight attendants, a Denmark study, Seattle case control study, nurses' health study. That was actually a very large study. Nurses in Norway, shift workers, and then there's a prostate cancer in males. All of them showed direct correlation between the amount of light, the amount of disruption of circadian rhythm the amount of melatonin suppression, and the more rapid rise of cancers. It's not so much that the light causes the cancer, it's just when you get it, it can accelerate much more rapidly. We're always, I should state this, it's an obvious for physicians, but we produce cancers all the time. Okay, I want to do cancer cells in you right now. The issue is we kill them off on a regular basis. Cancer cells is simply a cell's mechanism that's gone bad. And there's some breakdown in the cell or the DNA that's been disrupted, and it wants to grow. In normal physiology, you have T cells, C cells that recognize it as defective and kill it. The problem is you need a normal physiology to do that. So if you disrupt by suppressing melatonin, then you don't kill off those cancers that are always popping up. And that's what eventually happens with light suppression and melatonin suppression. And that's felt to be the reason why the circadian rhythm disruption may develop cancers. We produce them, but we can't kill them off or fight them off like we normally do. Okay, so the World Health Organization has an arm called the IARC, and they look at cancer tumorigenesis and try to rank what types of effects are the relative risk of different effects. For example, smoking. The tobacco companies love to continue to say there's no direct evidence that tobacco smoke causes cancer. Technically, they're correct. I can't give Tony a cigarette right now and come back tomorrow and say, aha, I just caused a cancer. It's not that direct. I won't give you a cigarette though.
Good.
Okay, good. So that's why it's not, smoking is not a group 1, direct carcinogenic. It's a group 2A, probable carcinogenic. That is the reason, because it takes many years of smoking, many genetic mutations of the damage of it. But I mean, I can tell you for a fact, smoking is bad for you, but it's a group 2A. So smoking is group 2A related. Based on the studies I showed you, and several hundred others I don't have time to show you, the World Health Organization, several years ago, say that circadian rhythm disruption is a class 2, group 2A carcinogen. Okay? So they're basically saying this mechanism is equal in known proof to tobacco smoke in terms of causing cancers. This is not a theory any longer. So shift workers are at higher rate. This is Lancet Oncology, just recently. That's the working group that finally declared that, December 2007. Okay, sleep duration. People who sleep longer do have lower rates of cancer. It means, of course, as amateurs we're all screwed, but what the heck. I'm still going to observe. So circadian rhythm disruption and cancer. I'm not going to spend a lot of time on this because it's pretty complex, but here's what Stevens from UConn has worked out. Phototransduction, neuronal signaling, pineal gland, and the mammary tissue. And here are the various genes which is isolated and hormone circuits that actually cause this problem. So there are a number of clock-controlled genes in our body. In fact, 10% of all our genes require a cycling during the 24-hour cycle. And needless to say, if we don't have that cycling, it disrupts to greater or lesser degree these types of genetic activities. All right, so they do. Okay. Breast cancer in young women is especially prominent. Why is that case? It's because if you have breast cancer pre-menopause, 80% of breast cancers in premenopausal women are hormonally dependent. Post-menopausal, it's only 50-50. All right, so here's some of the genetic pathways that lead to these clot genes that affect this. It's very well worked out at this point. I don't expect you to memorize this, but I just show it just to show you the amount of work that has gone into this and the number of genes that have been, in fact, isolated and shown to be part of this mechanism. So there are activators, there are repressors, and it's a 24-hour cycle that should work. This Takahashi is a researcher, not a telescope maker, by the way. All right, so here's some of the genes specifically that are implicated in this. Again, we're just going to go through them more to show you the amount of effort and work that's gone into this in 20 years. So there are a number of case control studies. This is in Connecticut, actually, 441 cases before therapy and hypomethylation, the melatonin causing methylation is strongly associated with the risk of developing these cancers. So, yeah, pretty much done here. There are ways that we don't have to have this kind of lighting. We can use reflectors, we can use shielding. We can know about this problem so that we can help guide actually human therapy. Which is the real reason why I'm interested in the subject. And no good talk at an astronomy conference can end without a couple of astro photos. So enter theme, of course that. I'll stop there. Any questions? The obvious question he asked was, why not just take melatonin and how does that help suppress it? Unfortunately, those studies have been done and there's no suppression. The oral form does not, it helps you sleep better, but it doesn't in any way help prevent the tumors. So unfortunately, that's multiple studies have shown that totally failed. We don't know why.